Imagine a beginning so profound, so utterly without precedent that it rewrites every rule you thought you knew about reality. Most people envision a colossal cosmic explosion, a fiery boom ripping through an empty void. But what if I told you that iconic image, the one seared into our collective consciousness, is fundamentally wrong? What if the universe's true origin wasn't an explosion in space, but the explosive beginning of space itself? The Big Bang Theory. It sounds intimidating, a dense jungle of astrophysics and quantum mechanics. Perhaps you've tried to grasp it, only to be overwhelmed by jargon or oversimplified analogies that leave you more confused than enlightened. Today, we're cutting through the noise. By the end of this video, you won't just understand the Big Bang, you'll possess a profoundly new perspective on your place in the cosmos, a journey from cosmic singularity to the stardust you're made of. Let's dismantle the biggest misconception first. The Big Bang wasn't a bomb detonating in a pre-existing void. Think of it not as an event within space, but as the expansion of all space and time from an incredibly hot, dense state. Imagine an uninflated balloon. Now draw countless tiny dots on its surface. As you inflate the balloon, the dots don't fly off into the air. They simply move farther apart from each other on the surface of the balloon. There's no center to this expansion and no outside for it to expand into. The universe is the surface. This analogy, though imperfect, is far closer to the truth than any explosion. Now, how do we know this isn't just a grand philosophical idea? The evidence is all around us, quite literally. Perhaps the most compelling piece of evidence is the cosmic microwave background, or CMB. In 1964, Arno Penzias and Robert Wilson, two engineers, were trying to get rid of persistent static in their new microwave antenna. They tried everything, cleaning pigeon droppings, checking equipment, but the static remained, a faint, uniform hiss coming from every direction in the sky. They had accidentally stumbled upon the afterglow of the Big Bang itself. Imagine taking a baby picture of the universe, roughly 380,000 years after its birth. That's what the CMB is, the earliest light we can detect, cooled and stretched over billions of years into microwaves. Data from satellites like COBE, WAMUP, and Planck have since mapped this faint glow with incredible precision, showing tiny temperature fluctuations that are the seeds of all galaxies and stars we see today. Another cornerstone of the Big Bang theory dates back to the early 20th century. Astronomer Edwin Hubble observed that distant galaxies weren't just moving, they were almost all moving away from us. Even more remarkably, the farther away a galaxy was, the faster it appeared to recede. This isn't because we're at the center of the universe, but because space itself is expanding, stretching the light waves from these distant objects, a phenomenon called redshift. Think of those dots on our balloon again. As the balloon inflates, dots farther apart appear to move away from each other faster from any given dot's perspective. Hubble's law, as this relationship became known, provided the first robust observational evidence for an expanding universe, turning theoretical physics into undeniable fact. So we have an expanding universe and a faint afterglow, but where did all the stuff come from? The Big Bang Theory predicts that in the first few minutes after the initial expansion, the universe was hot enough to act like a giant cosmic oven. Protons and neutrons, the building blocks of atomic nuclei, were rapidly fusing together. This process, called primordial nucleosynthesis, created the lightest elements, primarily hydrogen and helium, with trace amounts of lithium. And guess what? When scientists measure the abundance of these elements in the oldest parts of the universe today, they perfectly match the predictions made by Big Bang cosmology. It's a powerful confirmation. The universe wasn't just expanding. It was forging the very elements from which everything, including us, would eventually be made. While the Big Bang Theory provides an incredibly successful framework, it's not a complete picture, and that's precisely where the cutting edge of cosmology lies. For instance, we observe that galaxies spin faster than the visible matter within them suggests they should. This implies there's an unseen, mysterious substance providing extra gravitational pull, something we've dubbed dark matter. And then there's the truly baffling discovery from the late 1990s. The universe's expansion isn't slowing down due to gravity, it's actually accelerating. This implies an equally mysterious force, pushing space apart faster and faster, which we call dark energy. These aren't flaws in the Big Bang Theory. They are exciting new puzzles that show just how much more there is to explore, pushing our understanding to its very limits. So what have we truly learned? The Big Bang wasn't a chaotic explosion, but the elegant, ordered genesis of space, time, matter, and energy. From an unimaginably hot, dense point, the universe unfurled, cooled, forged the fundamental elements, and painted its baby picture across the cosmos. Every atom in your body, every star in the night sky, every galaxy shimmering across billions of light years, all are direct descendants of that initial cosmic expansion. You are not just in the universe. You are a profound, intricate product of its entire 3.8 billion year history. This isn't just a theory. It's the grand narrative of existence, making the distant stars feel a little closer and your own existence a little more miraculous. Now that you have this deeper understanding, what's the most mind-bending implication of the Big Bang Theory for you personally? Drop your thoughts in the comments below. I'm genuinely curious to hear your cosmic revelations. And if you're eager to unlock more secrets of the universe and broaden your perspective on reality, make sure to hit that subscribe button for SpaceRepo and join our community of cosmic explorers.